Math 13 students, hello. I have a little bit of a lecture here on section 9.3, matched pairs. If you will follow me over to my other screen, we shall get going. Almost there. There we are. Section 9.3, match pairs. So we have two match samples. Selection into a first sample, control selection into the second sample. Common examples are before and after. If we have some sort of specific treatment, as you'll see in the examples, if you are in the before sample, we want to also see you in the after sample. If we're looking at a husband and wife or other couples, if one half of the couple is in the first sample, the other half of the couple will be in the second sample. Body symmetry. If my left hand is in the first sample, my left hand is going to be in the second sample. Excuse me, my right hand is going to be in the second sample. So because of this, what we do is we focus on the difference between the two samples. We have special notation that that works very well with that. Little d is the individual differences we'll find in our table. D bar is the mean of those sample differences. S with the little d is the standard deviation of those differences. And little n is the number of sample pairs. Mu with the little d is the population of differences. This is the population we are actually testing. So I'll review the notation. The null and the alternative hypothesis. Mu sub d equals 0 is our standard null hypothesis. And then, of course, the alternative can be either a right, left, or a two-tailed type of test. It's important to note that the fact that mu sub d equals 0 in the null claim is the claim that there is no difference. On the other hand, the alternative means that there is some sort of meaningful difference. Once again, this is important. The null hypothesis, no difference. The alternative hypothesis means we have some sort of difference that exists. There are two requirements. They are the same requirements we utilize with a t-test, because that's the test we use here. We want a simple random sample, and either or of the following: n greater than 30, or the difference population is approximately normal. So we're going to assume for my examples here that the requirements are met. So let's take a look at an example. We have a claim here. We have a claim that a new med reduces blood pressure. And as I say, what we are really interested in is the difference, the before minus the after. So I have to do a little bit of subtraction. And by the way, we're going to come up with a much better way to do it than this. 164 minus 160 is 4. 48 minus 145 is 3. 179 minus 171 is 8. 152 minus 154. Notice that one is a negative 2. And then 175 minus 170 is a positive 5. So this is the sample that we are really interested in right there. Now, we're going to use a t-test with an alpha equals 0.05. We've got to write the null and the alternative hypothesis. This is a little bit tricky. Notice that if I take a look at the first pair of data points, this did what we would like the medication to do. It lowered the blood pressure. It went from 164 down to 160. So when we reduce our blood pressure, that means the population of differences should be a positive number. And that's what I need to investigate. So I'm going to write the null and the alternative hypothesis. Looks like I've got the alternative here. And then we're going to go ahead and take a look at the keystrokes. So we have H naught mu sub d equals 0, H1 mu sub d is greater than 0, and that's our claim. So now, come on with me over to my calculator. I'll share my screen and we'll take a look at the keystrokes. I've already preloaded my calculator with the before and the after data for the meds. And what I need to do is to find their difference. I could enter those numbers, but there's a much better way to do it. I highlight the list name, in this case, list 3, second list 1, minus second list 2. And I'll go ahead and I'll hit enter. And there's my data set. This is what I'm interested in. So that's the data set I'll use. Stat, over to tests, pull up the simple t-test, just like 8.3. We have raw data here. We don't have stats, we have raw data. There's my null hypothesis. The difference is equal to 0. If need be, I can go ahead and input the correct list. I make sure I've got the correct null hypothesis and then the correct alternative hypothesis. Greater than 0. So we're all set there. Now I'll just hit calculate, and I've got my p-value. I also have that d bar in the S sub d. They don't honor the notation, but that's what we are looking at here. So with rounding is 0.0460. Let me note that. And stop the share. And we'll finish this problem up. So p equals 0.0460, 0.0460, 0.05. 0.04 is less than the 0.05 every day of the week. So we will reject H naught. That means we're going to go with the alternative, which was indeed our claim. So to address the original claim, at alpha equals 0.05, data support, mu sub d greater than 0. What does that really mean? So the meds appear effective in lowering blood pressure. And that's a good thing. All right, so that takes care of that one. Now, what we can also do is we can also construct confidence intervals for the same difference of data. We have a point estimate, d bar. So if I come back to my calculator, clear my screen, I can come over and pick up the t-interval tool. I have data. It's already pointed at list 3. We're going to construct the 90% confidence interval here. There's my calculate. And I get a 0.12 on the low end, 7.1 on the high end. So 0.1 less than mu sub d less than 7.1. So we're talking about blood pressure readings. My point estimate is my d bar, and that's on that screen too. It is 3.6 points. And the standard deviation is also there. I'll write that down for completeness sake. That's also 3.6 points. So I can go ahead and construct a confidence interval as well as conducting a test. I have one more example. Here's a claim. Tutoring will raise exam scores. We're going to write the null and the alternative and going to use the same test. Now, This one's a little bit different. I want to take a look at the before and the after. My first score raised the exam score from 67 to 68. Not a lot. 67 minus 68 is a -1. So when exam scores are raised, the difference should be a negative number. Sometimes students have trouble with that, but that's understandable. But in this case, the difference is negative. And that's what means that tutoring was effective in raising the exam scores. Let me go ahead and stop my share and show you what I've done. So as I say, tutoring will raise exam scores. We have before and after. Mu sub d again is less than 0. You've really got to investigate what's happening so you can get the correct alternative hypothesis. So once I've got that, I can go ahead and write down my test. So in this case, we have H0 mu sub d equals 0. H1 mu sub d is less than 0. And again, is our claim. Let me share my calculator screen and we'll go through those keystrokes. You'll have one more example for your perusal. There we go. Let me clear that off. Come over here to stat. The edit. I have the data in list 4 and in list 5 for this problem, so I'll use list 6. Second list 4 minus second list 5. Hit enter. There's the data set that I'm interested in. Stat. Pick up the t-test. I have data. Mu sub d equals 0. But this time, I'm going to change to list 6, because that's where my data is. I will also change the alternative hypothesis. I'll hit calculate. I got an alpha of 0.05, and I get a 0.08890. All right, so that's my p-value. And again, I've got the d bar and the s sub d here also. There, stop my share. And we have 0.0889, 0.05, greater than the 0.05, so we fail to reject H0. So alpha equals 0.05. Data do not support mu sub d less than 0. The upshot is that the tutoring is not effective. At alpha equals 0.05, but if I had a 0.010, if my alpha was 0.10, in that case, my p-value is less than my alpha, and we reject H0. And that's only if. But it's worth noting that it's a fairly reasonable p-value. If the alpha was a little bit larger, we'd be rejecting it, and we'd say the tutoring was effective. All right, that pretty much brings me to the end. Let me go ahead and come back to my other screen. So once again, you really got to look at examples from this to get the direction right on the alternative hypothesis. So you want to pick a pair of points that does what the claim says should happen, i.e. blood pressure going down, so the difference is positive, or test scores going up, so the difference is negative. You really got to investigate that. If you can do that, you're well on your way to getting this process right. I'll say goodbye for now, and we'll talk soon. Bye-bye.